So calling this video a special is kind of a little bit clickbaity, and I apologize for that. But what I mean is we're going to be looking at one particular welding rod, and I guess this ginger beer too, but I don't have that much stuff from Australia. But it's still special because us in the States almost would never have any contact with this rod. And not only that, we probably never used it. Now, before we get into that, I just want to talk about something really quick, and that's this ginger beer. I like it. They claim this is brewed in Australia. I got to say that you guys over there are making some good ginger beer. Now, it could be that this says it's brewed in Australia and it's not, and maybe you guys over in Australia think this is garbage, and I find that to be pretty common. Like anytime someone advertises something in the States here that, oh, some other country loves, you go to that country and they're like, that's crap, don't buy it. But hey, that's, I don't go to Australia, I've never been there. Seems like an awesome country, but this is what I can get from you guys to go with this, and I like it. I've been drinking this stuff for quite some time now, so that's awesome. You guys can brew some decent ginger beer. And let's talk about what we got in here. I ordered this from Australia, believe it or not, and I have not opened this yet. So I called my local welding store to get these, and what's in here are 7016 rods, okay? Or at least should be. 7016 is a low hydrogen rod, so similar to 7018, but here in the States, it is almost unheard of. There we go. Nobody uses them. And apparently in Australia, these are far, far more common. And before I pull these out, I wanted to share a little something else. I called my local welding supply store, or actually a couple of them. I said, hey, get me some 7016. You got like a 5-pound or 10-pound that you can get? And he says, man, I'll call you back. They called me back both places and said, well, do you want to buy $900 worth? And I said, what do you mean? And he said, well, we can get them, but you got to buy 200 pounds worth of the rods at $900. And I think the other place was like $800 to get them. And I said, holy shit, like, no, I'm all right. So then I tried to find these online and I couldn't find them, even on Amazon. And I literally wound up on eBay to get these shipped directly from Australia. So pretty wild on how I got these. And by the way, this is kind of done in a viewer response because a couple viewers had asked about these. So that's why I'm testing them. Now, I have no idea if this brand is any good. I don't know where it came from, to be honest with you. It's Hamp done, who knows, 7016 low hydrogen, 3.2 millimeters. These are 1/8-inch rods. Quantity 400 grams, which appears to be maybe 15 rods, thereabouts. Now, these were not stored in a hermetically sealed package, so whether or not these actually qualify the way they are now as a low hydrogen, I don't know. That's something we will test in this video, at least a simple test to see if there's any hydrogen in this. But let me open this up and then take one out and seal it up right away. Like I had said, if I can even find, over here. Like I had said, these rods are not common in the States. My understanding is you great people over in Australia use these as a root pass on pipe. I have heard, and maybe it's just a rumor, if I can get this open, that this rod runs like a combination between 6010 and 7018, which I like the sound of that, to be honest with you. I've never ran it, so I don't know what to expect. I'm just going to poke this through. And I'll set that there. Let me go get a 7018 to compare this to. All right, so here is a traditional American 7018 H4R. Size-wise of the rods, it's a little bit thinner in diameter, I would say, than the common 7018. Wire size of the rod appears to be identical. Beyond that, not a whole lot to be said, I guess. This is labeled as a smooth arc 16 or 10 or 14. I can't really read that. It says, yeah, smooth arc something, two numbers, E7016. Now, in this country, we have like 7018-1, which gives low temperature performance, and an H4R. The H4 is referring to diffused hydrogen per weld deposit amount, and then the R stands for moisture resistant coating. All of that nomenclature is gone off of the 7016. It's possible that this does not meet the same level of low hydrogen. It's possible that there are rods out there that do. I don't know. This rod is so difficult to get, and very little information is available in this country on it, so I guess it is what it is on that. Now, my thought of what we're going to do, since I have an idea of set points as far as it's going to run similar to 7018, so I'll probably start at 120 amps. Dig-wise, I'm going to set my machine to probably just middle of the road at 4, see how it runs. And we're going to run just a normal bead-on plate. I'm going to give my thoughts on it, and then we're going to dip it in some mineral oil and check to see if there's any diffused hydrogen in it that escapes. So let's go and get set up and do that. All right, my settings are 120 amps. Hot starts at 3 out of 10. Dig or arc force is 5 out of 10. This does not have a graphite tip or anything, so it should start like a typical 7018 would be my guess. I have not ran any of these rods yet, so it'll be very interesting to see how they run. Let's see what happens. So running that, to me, it actually ran like a 7018, maybe a little bit crispier. Let me grab a brush. A little hot. To me, I mean, it looks just like a 7018 does, really. Hard to describe. It definitely ran more like a 7018 than anything like a 6011, but it had a certain crispiness to the arc that I'm not used to. The interesting thing, and let me show you, maybe it was me, but there does not appear to be a big glass ball at the end of this rod. Now, I might have just whipped it at the end, force of habit, but let's see how the restarts are. And I'll purposely not whip it at the end. Oh, of course, I whipped it again like an idiot. I'm not sure the video will show if I had a ball come off of that, but the restarts seem to be pretty easy on this. Far easier than 7018. Well, 7018, you can use tricks to make it run better. Let me do it one more time then, one more pass. All right, I did not whip it at all. Yeah, for sure. I'll zoom in here. I'm afraid to touch this sucker, it's so hot. You see how the rod tip is kind of held in there? It's like a concave there. On a traditional 7018, you get a ball of glass or silicone or something on the end that makes restarts really hard. This doesn't seem to develop that at all, so this is going to be a much easier rod to restart than 7018. Now I'm going to grab this and pinch it. Yeah, see, when you pinch it, it exposes the tip, and then it's going to restart like a brand new rod. Traditional 7018, if you leave that glass ball and on the end, you can't really pinch it like that. That's why when I weld, I'll weld it and then I'll drop that ball off at the end by doing that, and then you can pinch it like this, but this just doesn't develop that at all, so that's a plus. Weld-wise, this sucker's probably so hot I shouldn't be touching it. Oh yeah, you can see how hot that is. Oh, that's my glove, never mind. Well, that'll have to do for right now until that cools down a little bit. Bead-wise, it runs like 7018, but crispy. It's hard to describe it. I like the way this runs. Thumbs up so far. I'm gonna let this cool a little bit, and we're gonna check to see if there's any escaping hydrogen out of this. All right, I got this plate here. It's still plenty hot, which is good. Let's hold this in, and if we have hydrogen in the weld deposit that rod put in there, we should start seeing bubbles from this. There is a possibility, because these weren't stored in a hermetically sealed pack and they have not been baked out in an oven, that we may see bubbles. You can tell how hot that is based on the thermals. Let me drop that in, or kind of hold it in there. Now there's a lot of crap floating around in there, to be honest with you guys. So I'm going to let it settle for a little bit and really look at it. All right, with everything settled out, I saw maybe one or two things that could have been a bubble, but honestly that could have been generated simply from the little crater eye I left at the end. It's not really a crater, I guess, but anytime you have a little pocket, it can trap air when it's dropped. But from what I'm seeing, I don't see any bubbles, and if there are, they're very, very few and far between. So I would say this definitely qualifies as low hydrogen, especially compared to like 6010, 6011, which would have massive amounts of bubbles pouring off of it. Now, to meet low hydrogen spec with this from a like code work, you would probably need to bake these out in an oven since it's not a hermetically sealed pack, but it looks good to me, so that's awesome. Definitely better than non-low hydrogen rods. All right, let's move on. So this wouldn't be much of a test of this rod if I didn't do a bend test. So what we're gonna do is I got two more of the rods. I don't have many of them, but I'm gonna run a brand new rod on both of these fillet welds, 3/8 plate, and we're gonna bend one towards the face and one away, as I have done in previous videos, and see if this can match the strength of 7018. Now, in my opinion, I have not looked up the actual spec of what this rod has for tensile strength and elongation, all that. I have a feeling that this will keep up with 7018, but we won't know until we try it. And that's kind of the point of doing this. And I thought before I go and weld these, I'd mention something else that I forgot to. Apparently, these 7016 rods, maybe not this one, but like Lincoln Electric makes some, and ESUB and all these companies, a lot of them make them in this country and ship them overseas. However, like getting them here, very limited. My thoughts so far on this rod, I like the way it runs, and I didn't mention it either. not that I should be smelling it, but the smoke off of this, the fume, doesn't smell like any rod I've ever ran. It's hard to describe. It may be a combination of 7018 and 6011. It's definitely different. It doesn't smell like any rod. It's, you know, just from that alone, it's different, which of course the flux has a different composition, so of course it would. But with that said, don't go smelling the fume off of this, okay? It's not worth it. All right, let me get set up and I'm gonna run these and then we'll brake test them. All right, so here are our two test welds. Now, interesting thing, when I was running this, the puddle looks like 7018, but it deposits less metal, so realistically, my travel speed was probably a little bit higher than it should have been. I would say it deposits about 5 to 10% less metal than what I'm used to. Had I slowed down just a little bit, it would have probably fixed that. So these welds are, I would say, without a doubt, smaller than the same rod size in 7018. Now, this guy right here has a little bit of undercut right here, very little. This one right here is clean end to end. The ends are a little bit nipped off, to be expected based on this test. All right, this guy is air cooled off enough. It's, I don't know, maybe 80 degrees. I always allow these to air cool. You don't want to quench them fast. That will affect the strength. Let's break this. Now, 7018 in this test typically is between 70 and 80. Short arc MIG is 85, 90 to maybe 95 in that ballpark. 6010 is 90 to 100. So let's see how this compares. $66.9. All right, let's go and break the other one. All right, so we have it set up to do a bend towards the face instead of away. Now, this, I picked the best looking weld with no undercut to do this test, and this is a test where if you have undercut, it will aid in the failure of it. The previous test, undercut on the weld, isn't going to make much of a difference because it has to do with penetration more than it does the actual quality of the weld on the face of it. So anyways, I got this set up and we'll see if this sucker passes this or not. I'm kind of thinking it will. I don't know. We're going to find out. Don't worry, it didn't break yet. That's just the plate moving. Man, this is taking a hell of a lot of force. Oh, okay. Hate to grunt there, but... Well, would you look at that? No failure. Well, let's go to the welding bench and talk about it. Well, we have a pass on the bend away from the face, and then we have interesting results on the bend towards the face. So let's start out with this one first. So when we look here, we can see clear evidence, very minimal penetration at the start. I had the hot start enabled at 3 out of 10. I definitely need to turn that on up to maybe 5 out of 10 to get a hotter start with these low hydrogen rods. It seems to be a bigger issue with them. With more amperage at the initial start, it would probably fuse that together. Now this test, being that we bent it towards the face, is really a test that favors high penetration rods. That's why 6010 blows, you know, your 7018, 7016, all of these 70 series rods out of the water, and most 60 series. That penetration reduces leverage. But right here, cold start. It didn't look cold when you looked at the weld, but it's cold. The original plate edge is present for most of this, and that's likely why the overall performance was a little bit under what 7018 would have been. Now, I did run this at 125 amps. My thought is with a hot start of 5 out of 10 and maybe 130 amps, this would be about as good as it's going to get. So I would say realistically, even though this test is a little bit lower than 7018, you guys got to remember, I got probably 5,000 pounds of 7018 ran under my belt. So this being the third rod I ever ran, or second rod, is pretty decent, and I think I could do a little bit better, but realistically, it's in a ballpark of 7018, so low 70s, maybe it would hit high 80 foot-pounds on this test. Now, this one tended to favor the bottom plate that it broke off of. A lot of the 70 series rods seem to favor the top toe line in this case more so. Or a little bit closer to top or straight in the middle. So that's a little bit interesting. Now this did have slight undercut on the top, none on the bottom. So that really wasn't a contributing factor. But again, because this leveraged this way on it, it's going to kind of tear wherever it wants to and start on the edges. Performance, again, I would say very similar to 7018, maybe slightly less penetration, hard to say on that. I ran arc force of 5 out of 10. I think a little bit less arc force would have smoothed this out, and I could have slowed down a little bit and deposited a bigger weld, which a bigger weld wouldn't have helped it in this test necessarily, but it is what it is. Now let's look at this guy. So we have a pass. Now the top toe line on this has clear evidence of a crack or stretching on that toe. You can see that white line there. Hopefully it comes out. It's a little bit hard to see. So it was getting ready to fail there, much like the 7018 did. I thought it was interesting too, and I don't know how well you'll be able to see this. Let me zoom in. Maybe you can see there's a little bit of a shadow here, but there is a start of a crack right here. It didn't propagate any further. And I thought, oh, you know, that's interesting. The 7018 didn't have it, but I actually looked at a 7018, and sure enough, when I buffed it with a brush, it also had a tiny little crack in the same point. So quite interesting. Other than that, this weld actually hit the top plate more so than the bottom, and the bottom toe is a little bit cold. You can see that in there. It's kind of like a trough, just a little bit, not too bad. Again, my travel speed was a little bit too high with this. It just doesn't deposit as much metal as I'm used to. But I gotta say, it's a strong bastard. No issue there. I thought I would bring the 7018 test sample and compare it to the 7016. In the arc, what I saw is that the 7016 seems to freeze or solidify the puddle slightly faster. And you can kind of see that in the ripple pattern. It has a little bit more ripples where it's almost like it's solidified a little bit quicker. Not by a whole lot, maybe 5-10%. But both of these passed which I kind of suspected it would, but hey, it lived up to the hype. And the interesting thing is, and I don't think you can see that, but this 7018, when I cleaned it a little bit better, does actually have the same crack as this. So both of these were getting ready to fail, but realistically, I don't think I'd be able to make them fail because it would have just pinched these two plates together ultimately, and I would have maxed out the press. So low hydrogen rods are incredibly strong. Now on this bend towards the face, had a little bit less strength than 7018. I think if I fooled around with settings and had a little bit more practice with it, the performance would be very close. But based on what I saw, I'll give the edge a little bit to 7018 on that. But they're very close, very comparable. Now, as far as what do I think about this rod, honestly, I like it. I mean, no BS for never running it before. Never run it before. It welded great. I like it. Has a interesting property where it doesn't get that silicone bowl on the end of the rod, so it's a little bit easier to restart. It's too bad, I gotta say it, that this isn't available in this country, because I think a lot of you, us home gamers out there, would like this because it's a little bit easier to start and it's a little bit easier to restart with this. Actually, a lot easier to restart than 7018. I dipped it in the mineral oil and didn't see any evidence of hydrogen escaping, so it appears definitely to hold up to the low hydrogen specification. Now, this should be kept in a rod oven in the package I received. If this was in a hermetically sealed pack, you wouldn't necessarily need that. But based on what I see, I gotta say I like it. I have no issues with it. I think that you guys in Australia are you're onto something here, I guess. It's kind of unfortunate it's not available here. If you are in Australia or any country that actually runs this rod, let me know in the comments what you actually use this for, because what I saw on the nomenclature in this country, in America, is that they specify it as a pipe welding rod. So much like 7018 is often used for a fill and cap in this country on pipes, 7016 is likely used in the same manner in Australia. Now, I don't know what rod you guys over there use for a root pass. I have heard in the UK that you guys use 6013, so maybe you Australians use 6013 too. No idea on that. Hell, you might even use this as a root pass. Based on my experience, I don't think that the puddle solidifies fast enough to make it easy to run a root with a bad fit up. So from that aspect, I'm not sure what you'd really gain. But anyways, to not stroke this video out any longer than it needs to be, 2 thumbs up. And also, like I said, I like your ginger beer. Hopefully you guys like this too and I didn't just buy some marketing wink. Anyways, until next time, thanks.